Welcome back. Let's talk about unit prefixes in the metric system. So what unit prefixes are is essentially a merging of units in scientific notation. Unit prefixes are allowing us to include scientific notation in our values without actually having to write out the numbers themselves. The prefixes that we use for the units in the metric system are a representative of a scientific notation that's present there. So for example, if we say we have a millimeter, what that means is that we have 10 to the negative 3 meters, or 1,000th of a meter. But the same is true for a millisecond, or a milliliter. A milli anything is just 1,000th, or 10 to the negative 3 of that thing. In the same way, a kilometer, or kilometer, as we normally pronounce it, is 1,000 meters. A kilometer is 1,000 meters, in the same way that a kilogram is 1,000 grams. It's 10 to the third, positive 3, meters or grams or whatever the unit is. So these unit prefixes are allowing us to convey the relative size of these numbers with just the prefix. You don't have to include the scientific notation if you don't want to. So there are quite a few of these prefixes. The most common ones are shown here. So some of these you've actually seen before, a lot of these actually, I'm sure you've seen before. If you're familiar with computers at all, then you're familiar with giga and mega. So a gigabyte or a megabyte, it's the same kind of prefix here. A giga is a billion of something. Mega is a million of something. Kilo is 1,000. Deci, you probably have not heard of before, but a decimeter or a deciliter, that is 1/10. Centi, you've probably heard of before, because we use centimeters every once in a while. Here in the US, we'll use centimeters for something. So a centi whatever is 1/100th of whatever unit is we're looking at. So a centimeter is 1/100th of a meter. We already talked about milli being 1,000th. Micro is a millionth, 10 to the negative 6. Nano is a billionth. So 1/1000th is a nano of something. So a nanometer is a billionth of a meter. And so because of this, these two sets of numbers here, everything in each of those sets is actually the same value. So 1,000 kilometers is actually the same as 1,000,000 meters, because every 1 kilometer is 1,000 meters. And so saying you have 1,000 kilometers is essentially saying you have 1,000 meters, which is also the same as saying you have 1 megameter. Same thing down here, we have 1/1,000,000th of a meter, which is the same as 1,000th of a millimeter, which is the same as 1 micrometer. So once again, these are mostly used just for convenience. It makes it a lot easier to talk about things and understand their relative sizes using these prefixes. So let's talk about doing some unit conversions here. So if we're trying to take a value that has a certain unit attached to it and convert that into the same value still. So we're not changing the actual physical value of the thing we're converting. We're just changing the way that we describe it. The way that we do that is using what we call a unit conversion factor. And what unit conversion factors are is they are simply an equivalency, so taking two things that are equal to each other and placing them into a fraction. So for example, 2.54 centimeters is the same thing as 1 inch. If you take the actual distance of 2.54 centimeters and you compare it to the distance that is 1 inch, they are exactly the same size. They are the exact same thing. So 2.54 centimeters is equal to 1 inch. If we take those two numbers and put them in a fraction, doesn't matter which one is on top and which one is on bottom, these two things are both equal to 1. Because we have the same thing on top and bottom, the fraction as a whole is just 1. And everybody knows that if you multiply something by 1, you don't change the actual value. But because we have different units on the two different sides of our fraction, even though we're multiplying by 1, and so the actual value itself doesn't change, the representation, the way that it's shown, is going to change, because we can use these two different units to change the way that we're describing the value. So just as an example here, we want to know how many inches are in 35.4 centimeters. Well, what I can do is I can take my conversion factor that equates inches and centimeters, and I can say I know for every 2.54 centimeters, I will have 1 inch, because those two are the same value. And so if I multiply 35.4 centimeters by this fraction, by this ratio here, because this is equal to 1, I'm not actually changing the physical value of 35.4 centimeters. That actual distance is not being changed. What's going to happen is, because I put centimeters down on the bottom here, and I have centimeters on the top here, those two are going to cancel each other out. The units cancel, which leaves me with inches as my unit. Now notice here, only the unit canceled. The numbers didn't cancel. Those are still there, but the unit went away. And so if I do that math now, I have 35.4 divided by 2.54. That is 13.9. And actually I have to cut it off there because I only get 3 sig figs. So 13.9 inches. So that is the same physical distance as 35.4 centimeters, only now we're describing it in inches. So let's do the same thing here, but now let's convert the amount of Mountain Dew in a 2-liter into gallons. So we have, let's see, hold on just a second. How many gallons of Mountain Dew are there in a dozen? Sorry, I should read my own questions more carefully. We're trying to figure out how many gallons are in a dozen of these things. First thing we want to do, though, is figure out how many gallons are there in one of these 2 liters. So we're going to ignore the dozen for a minute. If you wanted to go ahead and take the dozen into account right at the beginning, you can do that. There's a way of doing that. I'm going to show you a way where we ignore the dozen for a second and then bring that in at the end. So let's work this out here. So I know, actually do I know? I think I remember how many liters there are in a gallon. I want to say it's 3.875 liters in 1 gallon, I believe. You can pause the video and check me on that if you would like, but I do believe that is correct, that there are 3.875 liters in 1 gallon. So that is the equivalence that I'm looking for to make my conversion. So what I'm going to do is I am going to figure out how many gallons are there in 1 bottle of Mountain Dew. And so when I figure that out, then I can just take that number and multiply it by 12 to work out how many gallons there would be in a dozen. So I'm going to go ahead and I'm going to take my equivalence and I'm going to plug it into the fraction here, and I'm going to make sure that I put the liters on the bottom, because I want the liters on the top here to cancel out. So if I do that math, what it leaves me with is I have 0.516 gallons for every 1 bottle. So a little over 1/2 of a gallon. But I have 12 bottles. So if I multiply that number by 12, that will get rid of my bottles unit, so to speak, there. And it will tell me that in my 12 2 liters, I have 6.2. Let's see, actually I should have 3 sig figs there. So actually it would be 6. Just rewrite that, 6.19 gallons. Way more Mountain Dew than you should drink in a long time. But I hope the process that I went through there made sense to you. And oh, I forgot that I had those in there. It teaches me to not review these before I make these videos. So yeah, I worked through the problems there, and you can see I did the same thing there. Wow, I actually almost wrote it in exactly the same place even. It's kind of hard. Oh, I flipped the numbers around. Darn it. Okay, so you can see here how I did get a slightly different number right there. But that's because I flipped my 8 and my 7. Yeah, well, teaches me to try and do it from memory. So if I had those flipped properly, then I would have gotten 6.34. Still way more Mountain Dew than you should drink in a long time. Okay, so we have a few more conversions, but these I would like you to at least attempt on your own. Most of these are just converting from one unit prefix to either another unit prefix or to no unit prefix. So these are actually slightly more simple than especially this second one that we did here. So go ahead and attempt these conversions. So what I'm asking you to do here is just take the number that I give you on the left and convert it into the unit on the right. So give that a shot. Alright, I hope you attempted these questions. So we're just going to start here at the top. 0.25 kilometers. I always like to write the number that I'm working with as a fraction, just since everything else in the question is a fraction. I think it makes it look better and it makes sense to me. I'm trying to convert to meters, and I know that 1 kilometer is the same as 1,000 meters. And so this is going to end up being 250 meters. Those kilometers are going to cancel. Similar thing down here. Sorry about that. 304.01 mils. I want that in liters. I know that there are 1,000 milliliters in 1 liter. Put the milliliters on the bottom, so it canceled. So this is going to end up being 0.30401 liters. These conversion factors do not count towards sig figs, so whatever sig figs I had at the beginning, I keep the same number at the end. Similar thing here, 220.0 nanometers. I know that there are 1 times 10 to the 9 nanometers in 1 meter. By the way, if you did this slightly differently, and you instead said, I have 1 nanometer for every 1 times 10 to the negative 9 meter, the math is going to end up being exactly the same. This is essentially just 2 different ways of writing the same fraction. So that is going to end up being 2.200 times 10 to the negative 7 meters. Let's do the kilograms to megagrams here. So if we have 0.0063 kilograms, if I go back and look, kilo is 10 to the 3, mega is 10 to the 6, so there are 1,000 kilograms in 1 megagram. And so that is going to end up giving me, let's see, I should probably write it in scientific notation. So it would be 6.3 times 10 to the negative 6 megagrams. Alright. And so then the last one here, sorry, I'm kind of running out of space here, but 3.50 gallons. And then there was, for every 1 gallon, 3.785 liters. Let me make sure I got that right. Yes, 785, not 875. So that one I cannot do in my head. 13, let's see, I get 3 sig figs, so 13.2. Alright, so on that slide you might have noticed all the ones except for that last one, I did the calculation in my head. Hopefully I did them all correctly. You can let me know if I did one incorrectly. But that's one of the nice things about the metric system, is that when you're converting from one unit prefix to another, all you're doing is moving the decimal place around. You're not actually changing the number itself. You're just changing where the decimal point is. But in the English system, none of the conversion factors are like that. It's just, they're all over the place. It's a different number of teaspoons in a tablespoon than there are tablespoons in a cup, than there are cups in a quart, than there are quarts in a pint, than there are pints in a gallon. Like, it's a different number for every single one, and it drives me nuts. Absolutely nuts. So the metric system where everything is just in terms of an order of 10, much easier to work with. It might be a little bit harder at first, just because you haven't done it before, but once you get used to it, it will become your friend. Okay, last one, I believe. Yes, last one for this video. So go ahead and pause the video here and try to solve these unit conversions. Some of these are going to be a little bit tougher than others, but I want you to go ahead and try them out before I show you how to work through them. So go ahead and pause the video now. All right. So the first one here is not too bad. We have 45.9 inches. And if you know the direct conversion factor from inches to meters, more power to you. I do not. But I do know that for every 1 inch, there is 2.54 centimeters. And I know that for every 100 centimeters, there is 1 meter. So we can use as many conversion factors as we need, because we can multiply by 1 as many times as we need. So if you do that math, you come up with 1.1, let's see, I get 3 sig figs, so 1.17 meters. This next one here, 26.8 centimeters to feet. It's kind of the reverse of that first one. So you have 26.8 centimeters. We know that there are 2.54 centimeters in each inch, and there are 12 inches in every foot. So if I do the math here, this is 0. Why is it not letting me write there? That's very strange. Just write it over here, I guess. 0.87, and let's see, I get 3 sig figs again, so 879 feet. And notice here, centimeters cancel out, inches cancel out, and that leaves me with the feet that I have there. What about this one? Here we have units raised to a power. Well, we have 12.50 centimeters cubed, and we know that for every 2.54 centimeters, there is 1 inch. Now, if you just did that one conversion factor, you would only be 1/3 of the way. Because when you have a unit that is raised to a power like this, what that's saying is that you have that many of that unit. So it's not just centimeters cubed. What that really is centimeters times centimeters times centimeters. So because we have 3 of those units, we actually need to perform 3 conversions, 1 for each unit. So we could do that by writing in actually 3 different conversion factors, or we could just take this one conversion factor and cube it. And I would rather do that. Save me some space and some writing. So by cubing this whole thing, we actually will have inches cubed and centimeters cubed, which will cancel out those centimeters there. So if we go ahead and do that math, 12.5 divided by 2.54 cubed, we get 0.76. And let's see, I get 4 sig figs there. So that is going to be 7628 inches cubed. So not quite 1 inch cubed. But that makes sense because a centimeter is a good bit smaller than an inch. Alright, same kind of thing here for the centimeters squared to meters squared. Only this one's going to be a little bit simpler actually because we only have 2, and going from centimeters to meters is less troublesome since we're staying in the metric system. So for every 100 centimeters, we have 1 meter. We're going to square that. And that will give us 0.024 meters. Yeah, I ran out of space there. Meters squared. And then the last one here, you probably had to look up some conversion factors for this one. There's kind of a few different ways you can do this. If you did just look up a conversion factor, you could find one that just goes directly from meters to liters, or meters cubed to liters. The way that I like to do this, if I could not remember that conversion, which I actually do, but I'm not going to spoil it. So 1 meter cubed, I'm going to go ahead and convert that to centimeters cubed. So for every 1 meter, hold on, I should not have cubed that there. Pretend like that's not there. So just for every 1 meter, there is 100 centimeters. And I'm going to go ahead and cube that conversion factor to take care of the cube here. A conversion factor that you should know going forward in the class, not necessarily you shouldn't have known it yet, but 1 centimeter cubed is actually the same as 1 milliliter. And so we can just go ahead and plug that in here. 1 centimeter cubed is the same as 1 milliliter. And that will get us to our liters, because we know that there are 1,000 milliliters in 1 liter. Since a milli of anything is just 1,000th of that thing, 1,000 milliliters is the same as 1 liter. Alright, and so if we do all that math, we should end up with 1,000 liters, but I'm just going to double check to be sure. Yep. 1,000 liters. And again here, the meters cubed cancels. Centimeters cubed cancel. Milliliters cancel, leaving us with liters. All right. We will leave it there for now, and the next one we will finish this chapter with a brief discussion of density. So I'll see you there.